All right. So welcome to the Developers Chat on July 24, 2022. And we are 8 weeks from our alpha version. And I want to take the opportunity today to talk about the software and the structure itself in detail and about topics that are open and we have to address. So if you go to our website and you click on the development link in the menu, and then you scroll down to software development, then you will find a new picture, an updated picture, which is the software schematics. I try to do that too on the side. Okay. So, yeah, I think most of you are familiar with this schematic. I just updated it, and I want to talk with you about the things that are changed and what we're focusing on. So all the stuff that is gray is not the alpha version, okay? This will be the following versions. We're now focusing on the 3 boards, which is the Pi, the Jetson, a Jetson board, and a mini NUS. And what we also do not do right now is the cloud stuff. We do this in next year. And we will have the front end, which is the yellow part. So as you all know, we had to split the process load from the Jetson Nano to a Pi. So make a kind of a pre-processing on the Pi and creating a WebSocket for the material, the stream, that the tracker can pick up and does the motion detection, kinematics, and image recognition stuff. By this, the Pi gets a little bit more load, which is the INDI Services that where we want to attach the sensors. One is the camera of the fisheye. The second one is acceleration motion sensor from WitMotion. And the third one is a GPS sensor. So this is the very basic setup, and that's what we focus on it for the alpha version. So we keep aside on all the not that necessary, all the unnecessary stuff for now. So Christian, maybe you can give us a short rundown of the current development situation, and maybe team leaders can give us an update where they are at the moment and how we gonna solve the 8-week tight program.
Okay, Ido and me, someone has got some microphone on. Oh, okay, I think it's Sunchild. Would you please mute? Yeah, okay, better. Ido and me are working on the all-sky cam part. We've got a change in the optics from the pair gear to a new one, which covers much more field of view and is able to illuminate nearly the whole chip. We received the QHY183c Camera. This is working nicely, and we have gotten a software update. That was coming in the last week. We did a review on the PyINDI client and rewrote the whole SWIC connection part. So SWIC is a library that is used to address C code with Python. And we have to go for the whole properties that are available. So we said, okay, we do a complete run, There are some parts in it for a telescope mount that we do not need, or for filter wheels. But we said, okay, we're going it completely so we do not miss anything. And we rewrote the complete INDI base client class. So we are good to go for the next week to have any QHY or ZWO RZ camera or the video for Linux cameras in. And we then said, okay, if we are going to skip video encoding, and because it doesn't make sense that we first take the images one by one, put them into a video, load it to the WebSocket, and then take it from the WebSocket with a nano and split it into individual frames again, so we can skip the video encoding, we thought. And this is what next week is going to bring. So we have an update on that. And this brings in all the stuff for the camera at the moment. Okay. So the one thing we put up in the discussion group of the developers is how huge has a potential WebSocket to be to fit all the data in, because the Pi 4 is limited in memory, and we have to do some calculations, some pre-calculations about how much memory we can use, how huge the WebSocket can be, or if we have to use a different technology for putting data to, so other things like the Web GUI or the Nano can connect to. And we want to do it in real time. So we are reviewing some other technologies to do that.
All right. So this is...
What are you doing about the lens?
We chose the second one in our list. It's a Mikey one. It's called MK-3.5 because it has got 3.5 millimeters of focal length, and it's doing 220 degrees of field of view. And with the camera, I think we will be around 170, 180 degrees.
Awesome.
And but Tommy, we should talk about the opportunity you became. You got hands on that. Maybe a special lens can be produced for us.
Oh yeah.
I heard that you got some guys around that can do that.
Yep. Yeah, they do. That's what they do.
Okay. And if they can get us a lens, let's say below $120, it'll be nice. Because the Mikey one costs around here 160 euros. And we will get a model for on this Wednesday.
Cool. Yeah.
So.
All right.
All I need is the specs to tell them what we want to have, and then I can get a quote for building it.
Okay.
Yeah, Tommy.
Yeah. So
I will keep contact with you and talk about this in the next couple of days.
Yeah. Okay.
Talk about the optics and options for the US market. All right. So from this system concept, you see that the stream is going through the INDI and taken on with the master control program. That's also running on the Pi, right?
Yes,
okay.
The master control program is just a script that that takes an incoming event and calls some other event handlers. Let's say if the data is complete, it calls the archive management, and this is storing the data away. Or if there's an incoming event that is unclear, so it triggers the PTZ and says, okay, this one has to end anything. So, but because this is a script, it can run on the Pi and it doesn't consume up much of the performance.
Okay, but it still has to establish the database and controlling the database.
It has just to trigger the archive management.
Yeah,
because the archive management is writing to is collecting the data and writing to the NAS. At the moment, the data is completely in memory.
Yeah, okay, but
in the
as far
Neo4j
as
database.
as far as
That's
you
right.
told me once, is that the master control program also provides the naming conventions, so that
Yes.
the master control is actually in charge of giving an event a name, for example.
Yes.
Okay, so that will be still implemented. It's not implemented yet because, and
We do not have anyone that implements the master control program. We are looking for someone who can do that.
okay, so Nikola, are you still there? All right. Nikola, you were testing Neo4j as a database. Is this true? Nikola, can you hear me? We cannot hear you. Okay, I skipped the question until Nikola has dealt with his audio topic. Okay. There he is again. Nikola, can you hear me? Christian, could you hear him?
Nope.
No. Okay. So, messaging. We had a discussion on Discord the last couple of days about messaging. Rebecca, you were mentioning Kafka, Apache Kafka. Ido was mentioning Nuts.io. My question here is whether it makes sense to have two different messaging systems in the station, and maybe it is more wise and easier to handle if we only have one messaging system. What's your point, Christian and Rebecca?
Rebecca, do you want to start first?
I think that's better to have just one, just to simplify everything.
Mm-hmm.
That
I
article
agree.
I posted, that article I posted wasn't really about Kafka. It was more about the design pattern, the way that the code would be structured to organize the information and distribute it. And that's what Nikolai asked me, was if that article was referencing, was it about Kafka or the design pattern? And it was about the design pattern.
Okay, got it.
But then he asked, are we going to, I think he suggested Nats.io, which Ido and I have spoken about before, Nats.io. And that's what we were initially thinking of. But it looks like, and I wish Ido was here so he could explain it, because I'm not really familiar with ROS2. I think it's robot open source software. I'm not sure exactly what it's called right now. But I think it might be another messaging kind of system, but I'm not positive. But it was, something that we were doing for the long-term goal, as well as short-term, transmitting data to the GUI, but then eventually, from the station to the Sky 360 main database, and between the GUI and between other stations that a particular owner might have. They might have 4 or 5 stations. So we wanted to think of the big picture, but also focus on the small picture. Mm-hmm. And that's where we came up with Nats.io to distribute the messages. Mm-hmm. But yeah, Ido mentioned ROS2, so I don't know anything about that. But I trust Ido. He's really informative on that sort of subject. So, but I think Nikolai is back, and maybe he has something more to say also.
Nikola?
Yeah, but sorry, I did miss the beginning of the conversation. So I had audio troubles.
Okay, so we are talking about, because in 8 weeks we are focusing on the first alpha version. And that's why we have to discuss now about details. The time of experimenting and doing research is over for now, and we have to develop the stuff that's not developed yet or fit all parts together. And we are now talking about the master control program, which is running on the Pi that is actually the buffer for the Nano, the Jetson board for the tracker. So the Pi, by not only providing the WebSocket for the tracker, also gives the opportunity to run certain programs on it, and one is the master control program, which makes sense because the fisheye is our master sensor and blah, blah, blah. And the master control program is in charge of several parts. What I said before is if you go to our website and you click on development, then you can scroll down to software development, and then you will see the system concept, the software system concept updated version. That's the image we were talking about right now. So if you make this open in another tab and have a look at it. So this is on the left top part, that's this Pi board, and there are several processes running on. One is the master control program.
MCP and ASE, yeah.
Okay. And yeah, my question to you was, you were working with Neo4j the last couple of days, right?
Yeah, I did. I did work with Neo4j. I made a setup with Node.js and GraphQL. So now we have option of, I don't know, for some reason, if we want Graph API also instead of RESTful, we have that option, because this is what I did in past at some point. But yeah, I did play with it, and maybe I have some plans how to organize the data, and yeah, I did think about it.
Okay. So Christian, from your point of view, who shall go on with creating the database and establishing the connections? Is this an IDO stuff, or shall Nikola go for that, or do you want to go for that?
I was talking to Ido about the whole stuff, ROS2 and the WebSocket, and if he's pursuing the path with WebSocket or any alternative to it, then we all three could work together. So yeah, keeping the Neo4j stuff running, I would say go on with it. And yeah, Ido is going, maybe he's going to he's working on the ROS2 stuff in the WebSocket, so that I can focus on the hardware programming. I think this could be a good split up of the work.
Okay, Christian, would you mind to coordinate this between Nikola and Ido and yourself?
Yeah, I'm doing that. Okay. Yeah.
So Nikola, Christian is... Nikola is still there? No.
Yeah, I'm here.
Christian is contacting you, I think, within the next couple of days, and to meet with Ido and to talk more in detail about the master control program, right?
Yeah, sure.
Perfect. Perfect.
So I think Nikola has some good start with how the data stream could look like, and yeah, I think we can use that what you already have got, and see how we can contribute to that.
Okay. Yeah, I have a basic boilerplate which is running on Node.js, and in background it's using Neo. And if we don't want GraphQL, we can easily swap it for a RESTful API with Express.js. If we want sockets, it's also not a big deal. JavaScript world is really interconnection agnostic, so we can use whatever we want.
Yeah. Okay, we're going to talk about how all things fit together, and
I will fire up my YED. It's a tool for designing graphs and things, and I will make some proposals. I will share it with you guys, and then we can vote. We can merge the designs into a final design or something.
Okay.
Sounds great. Thank you, Nikola.
No problem.
This part is more or less captured by covered by Christian, Nikola, and Ido, right?
Yeah.
So, okay. I try to mentally skip bullets, you know. So the next part on this is something that is wrong, written by me. Rebecca, this word GUI server should actually be the WebSocket. Okay, this is just temporal. The WebSocket is the one that is fed in with data from all kinds of sensors and all kinds of devices attached, and so that the front end just picks up that WebSocket and creates its magic from that stream. My question to you, Christian and Rebecca, is what is missing in that part? What does Rebecca need to go on? Is anything there, everything there yet, or still in experimental mode?
We do not have any WebSocket yet, and we do not have any data to show. So Rebecca is just sitting on, let's say, some kind of black box without any content.
Yeah, that's why the WebSocket is so important, and that you can stream the image sequences to it. True.
Yes.
But there are other sensors and other stuff, let's say, that can be already streamed. Oh, so by the way, you were talking about the WebSocket the last
maybe
couple of
some
Okay,
maybe some kind of announcement. Ido and me were talking about having an input sequence, some kind of tag that reads in already saved MKV files. Maybe this could be a solution during the time we set up the live stream. So maybe someone can write some kind of routine that loads special MKV files and puts it in as data stream for so Rebecca can test her web GUI stuff.
Does that make sense if you switch from video stream to image sequence?
We need a read-in routine for the stored MKV files already, because if you want to review them, then you have to load them. And loading them to the WebSocket is the easiest way, so the tracker can be run too and everything else.
Ah, okay, true. Because the event is stored as a video, but on detection of the event, it is processed on image sequence. That's the difference.
Yeah, so this routine can be like that it reads in the video stream and then puts it out into single frames. And these were put on the WebSocket. This could be the solution for the read-in. But I'm not sure. But if we have someone who has some spare time and can do that, that would be great.
Like to create some basically fake WebSocket service that will provide fake data for Becca to integrate with.
Not fake data. We have got plenty of data stored on the hard drives, and if we have got a routine to just read it into the WebSocket, so the simple tracker can do its stuff, then that would be very helpful even for Rebecca. So she has some content to show on the web GUI. Just reading in the video and showing it on the web GUI could be a start.
Okay, Nikola, I hear you thinking about doing that. Is it true?
Yeah, I can. So basically, at some point I had an idea of this data bridge between the station and the GUI. And idea is that this data bridge will be like a centralized place for GUI to gather information and to notify the station about informations from the outside world. And it fits with our ideology to separate the box to make it less vulnerable and whatnot, because we can disable our network access and use only this controlled bridge to communicate with the components. So
yeah, and we have with that we have already a read-in for the MKV files to the Neo4j database. This is in addition.
Yeah, it can be.
All right.
Do we have any protection of our data?
Not really now.
At the moment, no, yeah.
Except it being offline on hard drive.
So The thing is, Bojan, just to answer your question, the thing is, first of all, what's stored on the NAS is accessible by the user. If he puts out the NAS and puts it on a laptop, he can have access to the data. But this is not dramatic, because for now, until end of this year, we are working on our alpha and our beta version. And hopefully by beginning of next year, we have the first productive version out. Until that time, we store data locally on the rolling storage. So if the storage goes full, I think it's a 1 terabyte, or someone buys a bigger one, then if the last file is filling up the disks, then the first is deleted and rewritten. Next year, when we have the cloud service in place, then this is only a local buffer. And the real true data is then in the cloud service, in the cloud storage. The local buffer is for the user so that he can have quick access to the data and use the user interface, the GUI, to analyze the data, for example. So the second thing is that we want to provide images for the boards, not software to be installed. This has several reasons. One is that most people are not familiar with installing software on a Linux machine. And for second, it's a point of, if we give access, people can have access to the board, to the OS. By giving out an image, we can lock that in a way so that no one else has access besides us. By that, we can at least be safe, be sure, make sure that the software is not infringed or that material is compromised. But yes, the local storage is always accessible by the user if he just takes it out. That does not prevent anything. But at the time, at the moment when the event is captured, locally stored, it's immediately transferred to the cloud. So we always have the original. And there's no way of interfering here. Does that answer your question,
No.
Bojan?
Yeah, but my worry is about somebody can abuse our data.
Afterwards,
I
yes,
know.
yes, but we don't care. No, Bojan, we do not care. For example,
we do care.
No.
Why we don't care?
Yeah, because we have the original. If there is any material outside and someone comprised it because painted little aliens on it, for example, and says that's what Sky360 captured, then anyone in the world can go, because this image, this video has a certain reference name, and go on our server.
Hash.
Pardon me?
It's hash, file hash.
Actually,
hash, yeah.
file has digital signature.
Yeah, signatures, exactly. We will have that when we get to the cloud. And we'll compute hashes locally when we call the archive manager to store something in it.
Yeah.
And every frame that comes from the camera can be added some kind of watermark if you like, but we do not need that.
No. Crypto is better. We don't need to add information.
Our protection is we have the original. So if someone messes around with our material, we always can say, no, this is not our material, this is infringed material, and this is the original. Like NASA is doing it. Okay. Yeah.
The thing is, maybe finally, the thing is, if we would write some kind of encryption module that every data stream is encrypted, it will violate our license agreement, because we said we have a creative license, so the data will be free to anyone. We would violate this license ourselves. So we can't use any hard encryption, so just we can enter the data. After we capture it for ourselves, we are safe. What others are going to do with it, it doesn't matter.
Yeah, true. Yeah. Because we always keep the original.
Yes.
My question to you, Christian and Rebecca, for the GUI frontend is, and using the WebSocket on the Pi, is this now discussed and finally set as such that Rebecca can work with that, or is there still things in play that can be changed, will be changed?
I think from my point, we didn't decide yet whether we're using WebSocket at all or a different technology. But for the moment, we're trying to go for WebSocket. And I think it doesn't matter which one we take. I think just WebSocket is enough. And because correct me if I'm wrong, Rebecca, you just need the IP address and the port to have access to the WebSocket, any WebSocket?
I think so. Yeah, the
Yeah.
IP port. Yeah, I think so.
Yeah. So it doesn't really matter what's happening on our side. We just have to provide the IP address and the port to access any technology that.
Yeah, you just send it over to me in whatever format. Your video, as well as hopefully something like data in JSON files when that's needed to be sent over if it's not in a database. And just send it through the WebSocket and just let me know what format we're receiving it in, so that way we know how to accept it, to write code to accept it and display it on the GUI itself.
Yeah.
It's like
Rebecca, I have a question for you. How is our GUI is protected?
The GUI itself, how is it protected?
Yeah.
Well, I know that what I've written so far, I have it set up so that you have a user ID and a password to access the admin page to make updates to it, to update your latitude, longitude, GPS, that sort of thing. But that's it so far. That's it.
Okay.
My worry is lots of lunatics around here. They can do whatever you want, but in order to protect the purity of our data, this is very worries me.
Okay, I see. So you're saying, like, if the Sky 360 station is sitting out there by itself somewhere, somebody could run over to it and use the GUI right there.
Yeah, technically, if it's on open network.
But data we send into the cloud can be breached.
Oh, I see. That's. I mean, I'm not a data security person, but I'm sure that we would be sending it, via HTTPS, which is already secure.
Yeah, exactly.
As it's being transmitted. But point of origin and then destination, that's a whole different matter. But
okay.
I think Nikola was
the thing. Yeah, the thing is that the web GUI is running locally on the machine in your on any machine in your own network, and since the station is connected only to this network, to the intranet, if you may call it, someone has to get access from the outside to that particular machine, protected by any firewall, any router, or any router at that point. So you have to get access to the intranet at first. And then with the web GUI, you can't alternate the data. You can just view it. So you do not have any access from the outside to it. Only if we upload it to some kind of cloud service, I would say next year around this time, maybe, then we have to worry about protection for uploading the data.
I mean, it worries me, our goal to have purity of data. Purity. So my worries is about how can we I'm not, I'm not into it, protecting data and stuff like that. But
Yeah.
very
So
worried.
as long as the data is within the intranet, there are no worries because you can't access them. You can't alternate them. Only if you bring the data outside your own system, so by uploading to the web, let's say, then you can have a man-in-the-middle attack maybe, but therefore we can provide maybe IP masquerading. There are stuff to protect the data stream to outside. But as long as we are not having cloud service, we do not have to worry about it that anyone, even the user himself, can't change anything within the data.
Is that the idea, Christian?
The user can view it, but has no access to it.
Is that the idea in the future? Is the cloud service? Or what's the idea? We're trying to look into like secure file storage for like, UAP videos, or just how do you secure data so it's not messed with? So we were thinking like Web3 solutions.
Yeah,
you guys are considering.
For the web services, for the cloud service, we do not have any concept at the moment because we skipped that to next year. And I think we will make use of some expert in this field to do that. But for the moment, the data is stored locally and there is no way of accessing it for third-party members. So we collect the data, we are running the neural network on it, and we're storing it. But the owner, the user of the station, has just read access, no write access.
That's what I meant. That's what I thought. So the
every digital file has a signature, right?
If you calculate it, yeah. And regarding this Web3 thing, there is a technology called IPFS, which can maybe be useful in next stages when we want to have data integrity and data replication and a lot of nice things which guarantee us that no one will be able to modify our data and to, I don't know, put some aliens in it or something like that, because by default it's secured by cryptography. And one side effect of this Web3 system is that popular content is hard to weed out from the system. I mean, if someone spots UFO and it gets viral, it will never come offline.
Yeah.
All right. So any questions or topics around that from the master control program to the front end?
I have one. So should I create this mock software to pretend to be a box, so to pretend to be a station, so Rebecca can integrate with it? I mean, in the meantime, while Christian and Ido are exploring ROS2 and WebSockets, so later on I can join them in a few days.
Okay.
Because next 2 days I have a lot of free time, so I want to do something.
Hey, cool. So your idea is to create that WebSocket from streaming, let's say, a video, MKV file?
I don't know, yeah, movies or something, just a constant stream for her to integrate, and I don't know, maybe few APIs where you can gather JSON data about current state of the station or something like that. But basically software for a fake station.
Yeah. Exactly.
Or maybe even to work on this bridge or something.
Yeah.
Good idea. All right.
Okay.
Rebecca, that would help, wouldn't it?
Yes, thank you. That would be wonderful, actually.
that you finally can start working. So,
Right.
so yeah, the SSD mini NAS is a given. Then the last part is the software that's running on the Jetson board, which is basically twofold, which is the tracker that incorporates motion detection, kinematics analysis, and image recognition. And for a second part, an archive management, just to store the stuff away.
Why is archive on Jetson?
Pardon me, once again?
Why is the archiving software on Jetson?
Good question, Christian.
It isn't.
Oh,
As
okay.
I mentioned before, the nanos should or the Jetson should concentrate on doing the ML stuff.
Yeah,
And every other thing should be done by the Pi. And if one Pi is not enough, we take another. Or maybe, as you pointed out some weeks ago, we skip that all and go to an ATX main board with some potentially much better graphic card. But we have to decide it afterwards. Let's see first how much data we'll get, if the Pi can handle it, and if not, we change that completely and go for a micro ATX board.
You know, one thing bothers me a lot. The Jetson is made for AI, made by NVIDIA, and this is like a video company. Why we cannot do the things on a Jetson Nano? I don't, you know, I don't.
The graphic component of the Nano is great, but the CPU and memory stuff is not that great. And the HGX, which is my favorite, it's too expensive. So the Nano was the version, because you could get it for about $100 those days. It was a very cheap solution, and we had in mind with Skyfleet 60 that all the components should be affordable. And we said, okay, let's try to use the Nano. If it can do all the stuff with the Nano, then it's great to have it. But it doesn't cost $100 anymore.
Yeah, 350.
Yeah, and for 350 plus, let's say 150 for the Pi 4, maybe it's a good idea to pursue Nikola's idea of having a micro ATX board with a nice NVIDIA graphic card. We have to see if we can manage it like this. This is a good idea. And we would have much more GPU power.
So we are talking about PTZ head or base?
The all-sky camera.
All sky. So your way, Christian, is to get as much better picture or capture better picture on an old cam than a PTZ.
No, the all-sky cam is for detecting the event, and the PTZ is for the closer look. So if we capture the ISS is our benchmark. If the ISS can be captured as one pixel on the all-sky cam, then we can do some tracking with it. We can say, okay, it's just the ISS because we have all the data about the ISS. We know when it will arise upon the horizon, what path it will take, and we can say, okay, this is the ISS, and we can identify it as it. But if we have a sighting, let's say, one pixel, very, very bright, is moving in very, very strange path over the view, we can run a neural network on it and see if the moving path does something that is impossible with Coanda effect, that it may change in brightness significantly, let's say from 1 pixel to 30 pixel, and shows us a blob or something like that. So behavior, look and feel of it, and maybe it starts somewhere, disappears, and reappears somewhere different, but is the same object, and you can track that with a neural network. So this is done for just detecting the event, and if we detect such an event, then PTZ is notified to say, okay, what's the geometry looking like? And so the PTZ slews to it and tries to track it and redo the analysis again. So we get much more data out of it. Therefore, we need something that can take a closer look, like the telescope you bought some weeks ago. Yeah. Because it gets you a much better view of it. But the field of view of such a telescope is very, very small compared with what the All-Sky Cam does.
Okay,
so the All-Sky Cam
is not the topic of September right now. It's in the gray, Bojan, as you can see in the schematic. So we focus on the PTZ towards fall or winter this year. So to have it a prototype by end of the year.
So what is my goal? What you proposing of my goal to do?
Just do what you are doing now, proceed that, and just take your time about it.
Okay.
So because what you're doing is not just crap that we won't use. No, what you're doing is that you're doing advanced work that we will need after the All-Sky Cam can detect anything. Because without this detection on the All-Sky Cam, you do not know where to slew the telescope, the PTZ to.
Yeah. No, I'm going to focus right now. I lost my time with antennas. What I did that, oh my goodness. But I'm going to focus my time on a motherboard right now. Sleep ring I will put behind, because motherboard actually I like to focus on one Teensy 4.1, 3 drivers and 2 encoders, and send to Christian to check it out.
Yeah.
This is what I'm going to do.
Okay,
now.
Perfect.
That's a good idea. But what you did with the antenna is not lost. It's a really good idea to put the antenna around the Maxi telescope, and this is a splendid idea. So don't throw it away.
You know what? This is secondary thing. You know, I was just I was thinking, but then I changed my mind. I said, hey, wait a minute. We need first PTZ set working, then we can work on antenna later. So.
Yeah, but you started investigating the 1.6 gigahertz stuff.
Yeah.
Do you have some result of it? And if you have some result of
it, no. Let me tell you something.
Just write it down so we know what you did till now, and we can proceed it afterwards. But write it down and put it on the drive.
Yeah, I'm going to write, like you said, paper, because even though if I'm not connect any antenna to software defined radio, I have some signals. So this is like something going on. Then I don't understand.
Simply, like an ambient broadcast.
Broadcast or some fake signals. Even if I connect instead antenna like a 50 ohm the
guys,
connector.
May I interrupt on this point? Sorry, Bojan, I have to interrupt you again. This meeting right now is for the alpha version that we focus on by end of September. everything that is SDR related is experimental phase right now. Okay? Please do not hijack this meeting for the alpha version. This is more software. This is not actually your part. It is software only for now.
I'm sorry.
Yeah, it's okay. Just telling you.
I love you too.
If I may go back to the last part, which for our software
I'm sorry.
is the one that runs on the Jetson, on a Jetson board. We try to make it all happen on the Jetson Nano, but if the Jetson Nano is not sufficiently strong enough, we have to go either on a higher version or go another route, as Christian proposed already with an ATX board, for example. But for now, I would not change anything. We go for a Jetson board and see where we end. Right?
Yeah.
Okay.
The lowest hardware possible.
Yeah. So what I learned from you is that the archive management, which we had attached to the tracker, and the same with the PDZ, had to move to the Pi. True? Christian?
Yes, I would say, because the master control program is running on the Pi, and the Nano or any Jetson board is just doing the ML stuff, the data is still on the Pi.
Okay.
So so an archive manager should go from there, and the NUS is connected to the Pi.
Yeah.
So it doesn't make sense that the
it.
Nano should access the Pi for triggering the archive management.
Makes sense. Total makes sense. Was just historic that it's still there. So I move it over to the Pi, which leaves us on the tracker with the 3 modules: the motion detection, which is now covered by Simple Tracker, the kinematics, which Lionel is sorry, Lionel is not here today, which has to be rewritten in some way so that we can have a better error calculation, a more true error calculation. And yeah, I think it needs a couple of days work from his side so that the kinematics are calculated correctly, and then those parameters, I think he works with 3-4 parameters, are then thrown into a neural network, so to train it and to classify those parameters.
Yeah.
The third one is the image recognition. Yannick, now you have to update us a little bit. Are you there?
Yes, I'm there.
Okay, great. So, did you...
okay, it's nearly 8 o'clock. I have to run. I'm going to because this session is recorded, I'm going to review the part that Janning is going to tell us, so I won't miss anything.
Okay, perfect.
So thanks for you. Thanks to you guys for the meeting today. I think we are a step further, and keep up the good work.
Thank you.
Bye.
Bye bye.
Okay, thanks.
Bye bye.
So Yannick, I just want to come back to where we stand with the image recognition or image sequence recognition. We have now 10,000 plus 1,000 images labeled with let's say
Yes.
some confidence level. Oh, Lionel, there he is.
Oh yeah.
And my question to you, Yannick, and good that Lionel is there. Hi, Lionel.
Hi.
Are you in a plane?
How do you do?
Oh, yeah.
No,
Looks like-
I'm in a train.
A train. So my question is, Lionel, just to give you an idea what we are talking today. Today is the 24th of July, and we only have 8 weeks left until we should have the alpha version, the first version. We were talking about all parts already, and the final part is now what runs on the Jetson board, which is the tracker consisting of 3 parts: the motion detection, the kinematics, and the image recognition. And I just skipped the kinematics for now. We can talk about this later because we just came to the recognition, image recognition part. And please give me an update, guys. Yannick, you created 1,000 and other images that were already labeled. Is this true?
Yes, that is true. Yeah, and I'm currently my news for this week is that I could get the simple tracker working now finally.
Perfect.
And Lionel, could you mute yourself?
Sorry.
Okay, thanks.
The training
and I just wrote Brad to send me a link with his videos so I can process them. And then Nikola would like to have images on the order of millions, I guess. So I will just run the simple tracker as much as I can and then fill up my external hard drive, and then I hope that Nikola can tell me how I can send this material over to him so he can work with it with his ML model. So that's my plan currently.
Okay.
And while we're talking about the millions of pictures, my idea behind it, because at some point I did made some unsupervised classification algorithm, which doesn't need labels or anything. But the problem with this approach is that it requires a lot of data, and after it's done, maybe 5% of data can be used with high confidence, and the rest of it is just undecidable waste. So this is why I at some point on machine learning I wrote some theoretical data pipeline where we go from the RAV Sky Hub videos to a bunch of labeled images which were labeled in unsupervised methods. So, and if we have like 2 terabytes of videos, we take, I don't know, 10 frames per second of an event, we would have a lot of images. And after we process with unsupervised method, maybe we will end up with like 10,000 of images of each class that we need to train our classifiers. So our optimized classifiers.
Your idea is a kind of a pre-process to generate the material for.
Yeah, and also because simple tracker can be configured, he has sensitivity thresholds and whatnot. We need to keep track of which config we used for simple tracker to generate images.
Oh yeah, good point.
Yeah. So this is what I had to say regarding the high amount of images.
Yeah, you still have material? Okay, Lionel, go ahead.
Yeah, just going to give you my update now as I'm arriving at the station. So so I got to say it now. Sorry if it doesn't mix with the other stuff. So about the Docker. So in the simple tracker repo in the GitHub, there's a Docker file already that has a build scripts for Jetson and for just a PC, I guess. So it's got all the commands for the CUDA support already developed, and so it's just a matter of running a Docker build, and you should have the image. But I tried that, and there was some hiccups. But my goal for this week is to have the simple tracker running on the Jetson using the Docker file that's already in the GitHub.
Awesome. Regarding this Docker, I did see that all the dependencies, CUDA and whatnot are installed, but the part where you copy the source files of a simple tracker inside of a container, this stuff is missing. I mean, this is what I do with my software when I want to containerize it.
Okay, so there's probably like a command to add or something like that.
Yeah, it's a Docker command called copy space dot to copy everything and then run.
Awesome. Okay, so that's it.
Okay, cool. So, okay, where to start next? So, the idea is, Yannick, that you shall create 2 million images. And you want to store it on a local drive,
Yeah.
and then give this drive to Nikola, or provide it to be downloadable somewhere.
Yeah, exactly. That's my current plan. And actually, I found when I looked through the Simple Tracker scripts, I found a comment by Mike, and he writes in the comment, the CUDA implementation is terrible. It runs at about 1/3 the speed of the CPU implementation on my laptop. So something is we have still probably something to work out concerning the CUDA stuff. And I currently don't use the CUDA setting. So there's a settings file. You can choose if you want to run it on CUDA or not.
Yeah.
So there's a simple option, and I haven't tried actually to use it, but I currently don't do that.
My question is, why 2 million images?
Because this one algorithm that I have is not that efficient, and he needs a lot of data before he is considered trained.
Okay.
Nikola, I don't understand why we need a strange movement of object is strange movement. Why we need that many images?
We are mixing movements and visual appearance, because trajectories will be extracted with kinematics analysis software, and this is a different task, if I understand correctly. And we need a lot of images to train our neural networks to differentiate between pixels of a bird and pixels of a plane.
Well, and in different directions. You can't have one picture of a UAP and expect it to be the same for every.
Yeah.
I mean, my point is, bird has trajectory. You can, airplane has trajectory. Helicopter has trajectory. Whatever. Why we need that many images to train AI to detect a strange movement?
Because AI is not as smart as humans. He needs a lot of examples.
Plus, if you have a plane that's going by like this on one image, I promise you it's going by like this on another image.
Yeah,
so you those shots to train the AI so that it understands that that's the same image or the same object.
I mean, a plane is not going tick-tock, left, right, fast. A plane going, direction without any left-right movement. So it is for me to understand why we need so many images to train the AI to detect a strange movement. This is
what
all.
Nikola is doing right now is
You're on mute.
A pre-process.
You're muted.
Oh, I'm muted.
Did I?
Thank you.
Richard.
So Bojan, what Nikola is doing is pre-processing the material that is in videos, so to create new training material. But it is already pre-processed, meaning we get rid of zero events, where there's nothing in it. We get rid of clouds, for example. Okay. And then we have all sampled, collected into buckets like birds and planes and so forth. And then we can train a new neural network on just the buckets. It's a pre-process, and this pre-process is unattended. And because it is unattended, And because of the model it is like it is, it needs tons of pictures, of video material. So,
okay.
Has nothing to do
I
with
got
our
it.
final training material, where we probably would only need 10,000. Can be, yeah. We'll see.
Yeah, it's possible.
It's possible.
Like 10,000 examples for a plane, and that's it.
Yeah.
But at first, we will need much more.
Yeah, true.
Nikola, do you have any idea, for example, when extraterrestrial vehicle moving fast and then turning left and right, how can you train the AI?
Well, that's Lionel's part. He's working with trajectories. I'm just working with shapes on images.
Are you working on shapes?
Yeah, I'm working
okay.
just on shapes.
Bojan, your question is directed on the wrong way. So I explained before that the tracker is threefold. It has a motion detector. The motion detector recognizes events in the sky and tracks them, meaning if there's one pixel moving, it just keeps this in focus, let's say, or it creates an event with the coordinates of that object that is moving. The second level is the kinematics, which only works if there is already a track and not only one event, one object, but it takes a certain time and have collected a certain amount of frames until it makes sense to make a kinematics analysis on the path. And the recognition, image recognition, is a third level, which takes the image material, which is only cropped from, it's just the object with a little boundary. Because image recognition on the whole fisheye doesn't make any sense, because first of all you have multiple events, and then you have events with very low signal to noise ratio, because a fisheye is a huge real estate and the objects are very small. And that's
so
why we
my
crop
question,
them. Yeah.
Okay, my question to you: when a PTZ set started, on a first level, second level, on a third level?
Can be started anytime. The decision is not, the tracker does not decide that. The master control program decides that. So, for example, if a plane enters the view with the first frame, the motion detection already recognizes, oh, there is something changed. There is a motion. There is an object coming into my view. With the second and the third frame, we have a track, because these 3 points are then connected with, let's say, a spline or vectors. From that point on, the master control program knows already, hey, there is a new event. If, let's say, a couple of frames later, maybe 1 second later, the kinematics tells us this is not normal flight behavior because it does not fly like a plane, it could be still something, it could be a bird, but it could also be something totally different. Then the master control program gets that information from the kinematics, telling it with a probability or confidence of 50% that could be a bird, for example. And then we have the third level, which is all parallel, running all in parallel. And the master control program gets, let's say, another second later the information with let's say 80% probability or confidence, we know that is a bird. So the master control program knows for any event, let's say, that is older than 3 frames, what to do, whether to send the PT set to that object. And it also depends, and this is something that you have to keep in mind, there's not always one event, it's always multiple events. So the master control program has to decide what event is the most important one, because we only have one PT set to steer to, which also takes time because it has to rotate, and you know that.
Okay, I got it.
So this is a multi-level approach, and yeah, it gives us, let's say, after three frames of an event, we already have the information, and the can decide what to do. But this is a
very
strategy we have to work out.
This is very fast. 3 frames. I mean.
Yeah, you have a track with three vectors. You got a track. So we were talking today about what is already there, what we have on software and libraries, what has to be connected. And my question to you is, Lionel, Yannick, Christian is not here yet, and Mike is not here yet. But what elements do we still have to develop so that these 3 modules coexist and work together? Let's say, from motion detection to kinematics, I know that we have to improve the error rate calculation.
Sorry, which the 3 modules?
Motion detection, kinematics, and image recognition.
Okay.
So if you do not have the schematic in front of you, go to our website and click on development and scroll down to software development, and then you see the system concept. And there's the tracker, and the tracker consists of these 3 modules, which run more or less in parallel. So the motion detector.
So currently there's no connection between kinematics and image recognition, right? So
there's no connection. So my question is now, what has to be done so that these 3 modules can work together in concert? So what I start with this. So first of all, we need the WebSocket so that the material can be streamed. And we need an event from the master control program, let's say a message, so that the motion detector can communicate with. But
so
locally,
I think that will be with ROS2 implemented. Intercommunication between the process for kinematics, process for image recognition. It will be connected with ROS2 messaging, right?
Yeah, or a messaging system.
Or any messaging,
yeah. Yeah, that's the idea. So that all communication is on messages based, and so that any module gives off its messages or can receive messages. But still, these 3 modules need to get how do you say this? I mean,
integrated.
Can they run separately? My question is now.
I actually had a question regarding this. There is an approach called microservices, and it's useful when you have a lot of modules and you can develop them in installation and then test them individually and later on wire them up. So maybe we should decide for communication, for messaging stack, and then each person can take its own part and make a little program with only this one module and with this messaging rules. And hopefully when we put them all in the same network and set where each one can be found, it will just work.
Okay.
That's an idea.
Okay.
This is what I plan to do with this fake WebSocket broadcaster for Becca.
All right. Okay. Yeah, and you have to wait until Christian and Ido tested the ROS too. You are in the same group. Sorry, that you 3.
Yeah, I'm there.
Yeah. All right then. Anything on this system concept for the alpha version I did not mention? I did forget. Anything you want to mention or want to talk about?
Yes. Quick question.
Yeah.
So, in order to run the Dockerized image on the Jetson, you need to install Docker on the Jetson?
Yeah.
Okay. That's all I needed to know. Okay. So is that suitable in terms of disk space and?
Should be, because Docker was designed to be run on the Linux, and it is using some component that exists for like 25 years. One system called.
What should be the host system on the Jetson? So
you should check out
Ubuntu on the Jetson first.
I think that NVIDIA provides image for Jetson, like the Raspberry Foundation provides for RP.
Okay, perfect. Thank you. That's it.
Check with Christian in IDO. They already have something running. Maybe they found something that works better. But it will be Linux either way.
Okay, great. So that's due for this week.
All right. Lionel, a question to you about the error calculation. Did you manage to improve that part?
No, I haven't worked on that lately. So I'm still at the point which you're aware of. That hasn't moved.
Okay.
Sorry.
Okay. Yeah,
but it will.
You don't have to be sorry. But yes, just for an update, just to know where we are.
Okay. No, it's just okay. So that's where I'm at. Okay. So hanging up now. Have a good end of weekend, everybody.
You too.
And, talk to you soon. Bye bye.
Bye.
Okay, I have to move on too. So see you.
All right.
Around.
See you, Yannick. Bye bye.
Bye.
So, is there anything left, Rebecca, Nikola, that you want to discuss?
I have a quick update.
Okay, go ahead.
It's not really, it's experimentation part. I did manage to lay down some foundations for a transformer-based visual classifier that works with sequences.
Okay.
I found a really nice example which shows how to feed video material, frame by frame, inside a neural network, and how to train it. And there is a nice data set which is basically a video, for example, tennis swing, golf swing, or something like that, and algorithm learns to classify between them. So it will be pretty much a drop-in replacement of data for our case. We just replace images of baseball swings with images of airplanes, and it should work. Yeah.
But this model, does this work also for this tiny material of 32 pixels square?
Yeah, it should be. It's because it's not like YOLO v4 where you download the pre-established and pre-designed network. It's basically configurable on each layer. Each layer of network, you can choose how many neurons you have and whatnot. And regarding this classifier that works, the previous topic, the classifier that works with single frame in isolation, I did create some really lightweight neural network. It contains only, it's scalable, but I managed to run it down to 200,000 parameters.
200,000, okay.
Yeah, it sounds a lot, but when you compare it with multi-million networks, then it's small in comparison.
Yeah, it still has to be processable.
Yeah, and I don't have my Nano with me. My Jetson, my Jetson Nano with me. So I don't know how will it behave on weak hardware, but it should be more performable, or how it's called. It should work better than bigger networks.
So basically you have a Jetson on the board.
Yeah, I have Jetson and I have Raspberry 4 8 gigs. I want to have reliable, reproducible setup like Christian and Ido.
Yeah, perfect. I think you three are a perfect match for that. Absolutely.
Yeah, we'll see.
Okay. Anything else, Rebecca?
No, I'm fine right now.
Okay. Thank you. I hope that you soon can start working when you get the WebSocket, and maybe Nikola can provide that in the next couple of days.
Yeah, that would be awesome.
All right. Anything else about the alpha version? If not, then I'd say we go for another topic. Let's talk about shortly about hardware, Tommy. You know that we already are decided on the camera. It's the IMX183, but there are still two brands that we can use. It's the ZWO and the QHY. From your point of view, do you have access to companies that can provide that for the US market, for example?
I reached out to both those companies, and I can buy from both of them. What I can do is I can buy as a distributor reseller. QHY already gave me quotes. Essentially, can't remember off the top of my head right now because I'm a little foggy, but I think it was like 25% off or something.
Okay.
So it brought it down from like I don't remember. It's like $9.99 is the list price, and it brought it down to like $5.99 my cost. So what I would do is just whatever the exchange, I'd have to tack on the exchange rate to that because that's at euro, not US dollar.
Okay.
Well, actually, no, that's a big question that I had to them. So hold off. Let me say this. They had quoted US dollars on their website, but I thought that they were dealing in euro because of the stuff they were selling in Europe. So I reached out to them just to confirm that it was in US dollar. I just haven't heard back from them right at this moment. But assuming that it's US dollar, then we don't have to worry about exchange rates or anything like that I have to mark up. If it is, then I have to, compensate for the exchange rate. That's all that I need. So I'm not looking to make a profit off it, obviously. We just want to get these out, as cheaply as possible.
Yeah, you have to cover your costs. I mean, you have booking lines for you.
Yeah, it's not. No. Yes, I don't think it's gonna be that bad. I mean, $10, $20 per camera. There's nothing. There's really no need to make a profit on. So
you import from Europe?
No, these would come from China. These would come from China.
All right.
Because ZWO or whoever owns the one, both of them are in China.
Yeah, both are Chinese. Yeah.
So I have to pay for the shipping of them here, and the only thing that I found out about that, just like I'm dealing with now on power supplies, you really don't want to order a whole bunch of them and stock up on a whole bunch of them. I mean, I guess if you're doing large volumes, it's worthwhile, but right now the shipping cost is through the roof. So if I order for example, I ordered 500 power supplies, paid $6 a piece, but by the time you add the shipping charge onto it, that doubled to $12. Yeah. So right now shipping sucks. So you would have to compensate for the shipping here into the U.S., but beyond that, that's the only expense we would have to worry about.
Okay. We were talking about optics. We did purchase today a 3.5 millimeter. Oliver, correct? 3.5 millimeter fisheye from Mikey.
Yes.
MEIKE, Mikey. A 3.5 millimeter. And we will get it in the next couple of days, and we will test it. So by end of this week, we will know whether this particular product is the right product for the QHY camera. If not, and we need a smaller focal length, let's say a 3 millimeter or even a 2.5 millimeter. I mean, the smaller you get, the more expensive they become.
Not necessarily. I'm the little bitty ones that I've got. I don't have one in front of me right now, but the little S mounts, those are, they're cheap.
Yeah, okay. These are the 12 millimeter aperture diameter. Now, the one that we buy now is It is
The M40.
outside. It is 60 millimeters, and the projection is a half inch projection. Yeah, and so the aperture is 60 millimeters, but no, it's the wrong word. The aperture is a half inch, and the, how is this called, Oliver? Filter diameter is 60 millimeters. Yeah, because the filter diameter is in front of the optic. Okay,
Yeah,
forget about that. So that's a 60 to half in 60 millimeters down to 12 millimeters projection, and we have to find out whether that gives us, let's say, the 180 degrees field of view, and how much of the real estate of the sensor is covered by that. So we want to cover as much as possible, but still we have to keep the center circle in the view of the chip itself, so not that the view is not cut off by the chip because it's offside or something like that. So in case that this optic is not the one we'd like to have, you have access to, Oliver shares the optic. So if you look on the share screen,
I see it.
So that's the one that we bought today for testing. So my question is, do you have access to optic companies?
Yes, several. We have not just the two that I sent to you, but we have some those are well-known brands that that are very popular in not just CCTV, but everything.
Mm-hmm.
Machinery, everything.
Chinon, computer.
And Computar are very popular. But we have some off brands that are more what I would consider OEM, that focus their whole business model is that they work with other camera manufacturers or whoever to provide lenses for, but they don't. It's not like they go out and they have a big name and a big splash and all that. That's the ones that I'm talking about approaching. There's one, I can't think of the name of it off the top of my head, but there's one in Germany that we deal with that my counterpart talks to all the time. And that's who we primarily, for our little M12 lenses, that's where we go to. But the reason why is because they're an OEM manufacturer. I mean, that's all they do is focus on OEM projects.
Yeah.
So they might be our best option as far as
Okay, so you got the parameters what we're looking for: a fisheye, 2 millimeters to 3 millimeters, something in between.
Bigger issue is the field of view. Do we want 180 degrees, 170 degrees? I think 170.
The sensor we use is a 1-inch sensor, and the aperture of the optic should be at least 30 millimeters. 60 millimeters is even better. So the bigger the aperture, the better. Yeah, that's basically it. And we want to have a projection of, let's say, 180, at least 170 degrees on the chip.
Yeah.
I mean, they can calculate this. They have there's a calculation. We can check that.
Yeah. I'll reach out to them on Monday and I'll let you know.
Cool.
Right.
That optic is for $160. So if such optic would be below $100, that would be very nice.
Yeah. What are you doing? Is that I didn't look. Is that crap? I didn't look. Is that a fixed focal? Was that a fixed focal, or did it have a manual focus on it?
That is manual.
No, it has a manual focus.
So how are we going to focus those?
So if it's not manual, if it's fixed focus, it would be more easy. But this has the opportunity to so if we have a fixed focus optic, then we have to rework the adapter, which we already do anyways. So there is an adapter. It's 3D printable. It's just a model we have to adjust. What Christian is now doing, taking this Mikey and finding the focus point so that the projection is on the focal plane. So he can move the optic vertically by turning it.
Yeah.
But for that, he of course has to fix the focal ring to a particular place and then adjust the adapter. So either way, either he goes to the end of the focal ring and adjusts the adapter, or if we get a fixed focal optic, like the Per gear was a fixed focal optic, then we adjust the adapter so that the focus point is exactly in the plane. So basically, doesn't matter. But I prefer fixed focal length, if possible.
Yeah, we'll see. My experience with the manual lenses is that they because they have no there's no we don't have anything built into it. It's literally a manual thing that we do. So therefore, what I've found is that it's good to focus in on, let's say, a 6-foot object, an object 6 feet away. But when you go 10 feet away, it's still within. But once you get 15, forget it. And on a fixed focal lens, it's not that bad. It can be a problem depending on what your parameters are for the lens. But for the most part, yeah, you really would prefer a fixed focal, because anything manual is going to have a short range on what's going to stay in focus. And I mean, yeah, we are dealing with that lens is also aperture on it, right?
But
iris on it, right? So you can change the iris.
It's iris, yeah, and it's a 2.8, and you have to turn that ring to the end. The same with the focal length. If you go to the infinite, Oliver is sharing again.
Yeah.
If you go to the infinite.
As far as I can see, we jump from 0.7 meters to infinite. Yeah. So my guessing is that we will go with the infinite adjustment anyways. So yeah, we could say it's just like. Sorry.
But what about the iris though? If you go with infinite, you're going to have to be really careful on what you do on your iris. And we're dealing with night and day, right? Yeah. So you've got you've got to have a 0.8 at night, and then whatever during the day, 8 or 5.6.
Yeah. Now we keep the iris as much open as possible, and we adjust the exposure by software.
Oh, okay, perfect. Yeah.
So we will always go with the 2.8 opening, and I guess with the infinite focusing. Yeah. And then when you look at the ring of the objective, you can see that it has structure. Yeah. And so we maybe can fix it with our adapters to put it in the station that it's fixed and it can't move.
Yeah, but
let's see.
Let's see. Yeah, true. But the camera and the optic is mounted on the enclosure and is covered by a glass dome, an acrylic dome, so no one can touch it. My only concern would be whether heat changes can loosen the ring, but Christian said that those rings are very tight, so they don't loosen that easily.
So I guess we have to think about vibrations too. We have a cooling inside, we have moving parts inside, so we will always have some movement, which we in any case should eliminate before it reaches the camera and the objective.
Yeah. But yeah, Tommy, you're right. Fixed focal length and fixed iris would be best.
Oh, I can't find it. Let me go to this website and show it to you. I was going to show you this little thing that we've got, but I can't find one right this second. We have this little, and this is something that we can build. This isn't something that, when I say we, I'm talking about us. It's not something that we have to go somewhere and have made for us, but give me a second.
Yeah.
Can you, I'm on my iPad, so can you go to this website and share the screen? Because it's a little hard to do on my iPad here.
Oliver, can you do that? Tommy's giving you a website name. Or
Yeah, hold on.
can you post it in the chat?
Yeah. Hold on, let me pull it up here on my computer. Come on. Why aren't you working? Cameras. Holy crap. You know, when you're trying to do something, the website's always slower. Okay.
The boiling pot never boils. A watched pot
Yeah,
never
right.
boils.
Those are the accessories. Oh, here we go. Actually, I can do this. I can take a picture of it and just, there we go. Okay, how do I share this with you guys? Can you stop sharing yours?
Yeah.
Yeah. Give me a sec.
See, maybe I should put it in here. Oh, there we go. I'm gonna put it in the chat.
Guys, sorry to leave you, but I need to go do something.
Yeah, no problem. Nikola, thank you for having you. And yeah, we'll see you on Discord.
Thank you, guys. Bye.
Bye-bye.
Bye.
Bye. Here we go. So is it going? I don't know if it's working. Look in your chat. Look in your. It's not posting. Why isn't it posting?
In the chat?
There's in the little chat room that we have here. It's not posting it in there. So let me go to the main chat. Hold on. Let me just go to where would I put this? PTZ. Look at the PTZ channel.
Oliver, can you go?
Yeah, I'm already looking. Yeah, okay. Now I somehow have to go back here and
Ah, yeah.
you mean this one?
Yeah. Okay. What you're looking at there is one of my POV cameras, but underneath it, it's hard to tell this, but underneath it is another body, another POV body that only has motors on the inside of it, and it allows it to be your autofocus and your not auto. It's focus and iris.
Yeah.
But what we did was that's all run by RS485, so it's real simple coding, nothing special in any way. Can be literally written in 5 minutes. And what we do is we have software that you can actually connect to this that either auto controls it or manually controls it. But this would give you the ability to have those type of lenses and then have the auto whatever.
Yeah, but actually we do not need this. We do not need focus because after 8 meters, it is infinite.
I'm just saying this does both.
Pardon me?
I'm just saying this does both.
Yes, it does. But it's a great product, definitely. But I'd like to use as few moving parts as possible, and such a thing is certainly a point of failure.
Yeah. Yeah.
And still
You mean someone will mess it up? Yeah.
And still we have to write the software for it and to maintain it and so forth. Oopsie, sorry.
No, I agree with you because there is an issue, an inherent issue that we don't like, and that is those rings that are around it, those gears, they're made of essentially rubber. And
they wear out. Yeah.
Well, and not only that, but they have a tendency to slip once in a while.
Oh, they're backlash. Okay.
Yeah, like they'll skip a gear, basically.
Yeah. Oh,
and
okay.
that's a problem. somebody can go up there and deal with it, but it's not like a CCTV camera where you mount it and never touch it ever again. Maintenance.
So I would rather go for a fixed focal and fixed
I agree.
iris. But if it's not if it's manual, then either the rings are very tight and you feel that you really need power to turn them. If it's rather loose, then we have to kind of use kind of a lacquer, Oliver, such a thread lacquer, for example, to fix it in place. Because it shouldn't be moved anyways. I mean, yeah, someone can think, I want to use it for my DSLR, but yeah.
Yeah, no worries.
Yeah, no worries about that. Okay, so
maybe
else?
one more thing.
Oh, yeah.
One more thing. I maybe had an idea. I don't know if it's a good one. We talked. Yeah, I know. So we talked about the direction of the station, which side is going north and east and so on today. Yeah, in the members meeting, and so someone raised the ISS today, and if we know that it's the ISS, we could detect our position and the direction our station is showing by the appearance of the ISS in the camera, that we know if where's north and where's east, or isn't that possible?
Das Pferd von hinten aufzäumen. So first of all, in order to find the ISS, we have to know where it is. So
when we use ISS tracker or something, you have all the data where it is, and
depending on the location you are and the orientation your camera is, then you can say it has to come there in 2 seconds. But if it can come from any direction in 2 seconds.
But when I know it's 2:30 by example,
in order to find the ISS, you have to know where it comes from, because we only see the ISS with between 1 and 2 pixels, and there are a lot of insects around us that are of the same size, and even fireflies in night are the same size as the ISS. So in order to fulfill our benchmark, we have to know how the station is oriented, because we say we fix the orientation of the camera within the station. We do this with an adapter that is only mountable in one way. So by that we know how the camera and the optic is oriented within the station, but we have no access to, we have no influence in where people put their stations and how they are oriented. So this orientation thing has to be done manually. For example, if you know your local station where you are because your GPS coordinates.
Well, maybe. Give me a second. Yeah, I know where you're going. Let me go one step back, please. So we have a GPS on board, so we know where the station is. Yeah. And then we know via ISS tracker or whatever, when the ISS should appear on that spot where we know where it is. And we get an angle, an appearance angle, and the time.
Yeah.
Yeah, but still
and then we should be possible. It's only about the orientation of the station. It's not about the geographical placement of the station. Yeah.
Yeah, but even if you know where the ISS shall show up, I mean, it shows up on a circle because you do not know where the station is oriented to. So you have to monitor the rim of the fisheye at a particular point in time because you know where the place is when the ISS shows up. But still, you have to watch that rim. And that rim watching is totally the same thing as watching the whole fisheye for a pixel that moves. It's You have to use much bigger optics to be able to recognize the ISS as a real object and not only by 1 or 2 pixels.
So I got a question. What if you can set up a schedule that tells the PTZ and the well, hold on. I guess it would be running it all the time. I was thinking that we already know from the app, because I played with it a lot, that it tells you exactly where the ISS is at all times. So we know where I'm at, where you're at. Doesn't matter where you're installing them. We know exactly when that tracker is going to come into play. I'm just wondering if that's not when we tell the PTZ. We set up a schedule that tell the PTZ that every certain amount of days that it points in this direction.
Yes, we can do that, absolutely. But in this case, the orientation of the station has to be known.
Yeah, well, every time somebody buys one, you ask them. And you log it.
Yeah, no.
Yeah, but people have to know.
No. Guys, this discussion is not necessary because the solution is too simple. So, in our user interface, there's a map, okay? And when you have your station in the center of the map, okay, then you can look at your view in the fisheye and say, okay, I see this mountain or I see this church or what have you. And then you go to the map and you click that mountain. And you say, this mountain is this object in this direction. And the software knows then, because 2 geo-coordinates are known, then it knows the direction. And it knows, okay, this is 20 degrees north, for example. Then it knows, okay, in the fisheye view, this dot there that is a church, for example, is at 20 degrees. So north must be 20 degrees to the left, for example.
So my suggestion was, because I wanted to avoid human failure. Yeah, maybe we go away from ISS. You can go with the moon as your orientation point also. Yeah, and it's big enough.
Only able to set up the station when we have full moon. So
yeah, but this is a control, Richard. No. Don't come up with that. Yeah, because you have to do it once. Yeah, and until you move the station, it's always the same. Yeah, that's just the idea to avoid human failure. I don't know if it's 18 or 20 degrees when I look at kitchen.
The moon is certainly easier than the ISS, used as an orientation point. Absolutely, totally with you on that. Yeah, Christian has to tell us this. Christian has the ephemerides and the software for that, so he can tell us when the moon is where. So, but then the tracker still has to find, where's the moon? What is a moon? Is this orb the moon? You know what I mean?
Yeah. Okay.
Okay, guys. I stopped recording for now.
Yeah.
Bye-bye to anyone.
Okay.